Successful modular construction does not begin when modules arrive on site or even when production starts in the factory. It begins much earlier, during the planning stage. In modular delivery, many decisions that can sometimes remain flexible in conventional construction must be made early. The team needs to think carefully about the design direction, procurement strategy, transportation requirements, factory capacity, financing structure, and risk responsibilities before the project moves too far forward. The reason is simple. These early decisions determine whether the modules can actually be manufactured, shipped, lifted, and connected efficiently. So, early planning is not just an administrative step. It is the point where the project team decides whether modular construction is truly appropriate for the project. If the project cannot support the discipline required for modular delivery, it may be better to choose another construction strategy. So, early planning is not just an administrative step. It is the point where the project team decides whether modular construction is truly appropriate for the project. If the project cannot support the discipline required for modular delivery, it may be better to choose another construction strategy. One of the most common mistakes in modular construction is deciding to use modular delivery too late. A building that was originally designed for conventional construction cannot simply be divided into several box-shaped modules at the end of design. Modular construction requires the building to be planned from the beginning as a coordinated factory-built system. This means the team must consider module size, transportation limits, lifting requirements, factory production, MEP coordination, and connection details very early. The delivery method also matters. Design build, construction manager at risk, and integrated project delivery are often better suited for modular projects because they allow the contractor and modular manufacturer to provide input during early design. In contrast, traditional design bid build can be challenging because the manufacturer may not become involved until the design is already too fixed. Another key issue is the design freeze. In conventional construction, late design changes can still be disruptive, but they are often handled in the field. In modular construction, late changes can interrupt material purchasing, shop drawings, assembly sequencing, and factory production. That is why the modular manufacturer should not be treated as a late supplier. The manufacturer needs to be part of the core project team before the design is finalized. Modular construction can provide major benefits, but it is not the right solution for every project. Before committing to modular delivery, the project team should complete a clear go or no-go suitability assessment. This assessment should look at several practical factors. The first factor is repetition. Modular construction works especially well when the project includes many similar units, such as hotels, apartments, student housing, military housing, or patient rooms. Repetition allows the factory to use a consistent production process, which improves efficiency and quality. The first factor is repetition. Modular construction works especially well when the project includes many similar units such as hotels, apartments, student housing, military housing, or patient rooms. Repetition allows the factory to use a consistent production process, which improves efficiency and quality. The second factor is site condition. Modular construction can be very useful on dense urban sites where staging space is limited. It can also be valuable in remote areas where skilled labor is hard to find or the construction season is short. The third factor is transportation. Volumetric modules are large and heavy, so the team must evaluate bridges, tunnels, narrow roads, tight turns, utility conflicts, and Department of Transportation limits on height, width, and weight. The main point is that repetition alone does not make a project suitable for modular construction. The project must also be buildable, transportable, and installable. Modular construction is often selected because it can shorten the schedule and improve cost predictability, but during early planning, the team should not only compare the initial construction price with a conventional estimate. The most important schedule advantage comes from parallel work. In a traditional project, site work and foundations usually come before most vertical construction. In a modular project, factory production can begin while site work and foundations are still underway. This overlap can significantly reduce the total project duration. For many owners, the real value of modular construction is not just lower hard cost. The value may come from earlier occupancy, earlier revenue, reduced construction loan interest, lower site supervision costs, and fewer time-related expenses. There can also be cost benefits from bulk purchasing, reduced waste, and improved labor productivity in a controlled factory environment. However, these benefits depend on repetition, factory capacity, transportation distance, and how well the design was planned for modular production. A major financial difference is cash flow. In conventional construction, payment is often tied to visible progress on the job site. In modular construction, a large amount of value is created off-site before the modules arrive. This means the owner, lender, contractor, and manufacturer must coordinate early on deposits, production payments, inspections, insurance, bonding, and payment procedures. This means the owner, lender, contractor, and manufacturer must coordinate early on deposits, production payments, inspections, insurance, bonding, and payment procedures. Instead of only managing field labor, weather, and site sequencing, the team must also manage factory production, transportation routes, module protection, tolerance fit, and final connections between factory-built and site-built work. One of the most important technical risks is tolerance. Factory-built modules and site-built foundations are produced in different environments, and they may follow different tolerance expectations. If the foundation embeds module geometry or connection points do not align, installation can be delayed and modules can be damaged. Transportation risk must also be identified early. Route studies, permits, escorts, specialized trailers, delivery windows, and weather protection all need to be considered before production begins. Factory capacity is another major risk. The manufacturer must have the experience, financial strength, labor force, quality control system, and production rate needed to support the project schedule. Finally, code approval and contract responsibility must be clearly addressed. The team needs to confirm how factory inspections will be accepted at the final project site and who is responsible for fabrication, storage, shipping, hoisting, setting, weather protection, and final connection. A useful tool at this stage is an early modular risk register. This register should be updated throughout design, fabrication, transportation, and installation. A strong example of early planning in modular construction is The Graphic, a multifamily residential project in Charlestown, Massachusetts. The project included approximately 136,000 square feet and 125 apartment units. It used 128 factory-produced modules for a new 5-story modular apartment building. The project team understood early that a conventional site-built approach would create schedule challenges, especially on a tight urban site. Because schedule reduction was a major business objective, the team selected volumetric modular construction. One important success factor was early team assembly. Tokchi Building Corporation and the modular manufacturer, RCM Group, were brought into the process during schematic design through a construction manager at risk and design assist approach. The team also froze major design decisions and shop drawings early. Before full production, the owner and design team reviewed mock-ups, confirmed interior finishes, and aligned quality expectations with the factory. The project also benefited from parallel production. While the concrete podium was being constructed on site in Massachusetts, the wood-framed modules were being produced in the factory. As a result, the project finished an estimated 4 to 5 months faster than a conventional approach. This shorter schedule reduced loan interest, lowered general conditions, and allowed leasing to begin earlier. The lesson from this case is clear. Modular construction creates value only when design, production, financing, and installation are coordinated before the work begins.